All right, so we will just pick off where we left yesterday. What were we doing yesterday? If you remember. We were just in the SOH CAH TOA stuff, yeah? And we were also doing the inverse, the second function of sine, cos, tan, yada, yada. This is going to be a brief summary of what we've done in this unit, starting from the very first thing we did about proportions, yes, similar triangles. Question number 1, are these two triangles the same? Or are they not? They're obviously not the same, but are they similar? What do you think?
Yes.
Yes, they are. How? Let's just label them, okay? A, B, C, D, E, F. How can we show that both of these triangles are similar?
They have similar angles.
Right, so angle CAB, right, is equals to angle FDC. E, I think that's an E. This is an E. Yeah? They're both 90 degrees, correct? And then we have the other one, AOB, which is the same thing as what? What's AOB? Not AOB, that's my bad. It should have been angle ABC. Which angle is the same thing as angle ABC?
DEF.
Right, DEF. Okay, and they're both O. We don't know what O is, we don't care. So therefore, triangle, look at the notation here. Those are angles, and then we have triangle ABC is similar. Okay, that's a symbol for similarity to triangle DEF. Now, what's going to be the scale factor? You can use any two sides, right? Scale factor K, I'm just going to say is ED over BA. Yeah. ED over BA. So that's going to be 9 over 4. And I believe it's 2.25. And that's our scale factor. Does it make sense? You remember this stuff?
I do.
Right, there you go. That was about similarity. The next one is also going to be about similarity. Check this one out. The orientation is a little bit different. Is triangle ABC similar to triangle DEC? Is the one on the left similar to the one on the right? What do you think?
Yes.
Which two angles are the same?
B and D and then C.
Yeah, exactly. So they were 90 degree there, 90 degree there, and then these two are opposite angles, right? They're always going to be the same. So they are indeed similar. The next question it asks is to find what P is. In order to find P, we first need to find the scale factor. What's going to be the scale factor here?
1.5.
How did you get that? 6 over 4? All right. If K is the scale factor is 1.5, what's P going to be?
$7.5.
No. P is not going to be longer than 5, is it? This went down, right?
Oh.
So this should also go down. P is not going to be bigger than 5. You don't multiply, you divide there.
So 3.3.
Yeah. Okay, centimeters, and there you go. That's the answer to this question. Hmm. See, there's questions like these, like, will you ever use them? Maybe, or maybe not. But the point of learning these is that because there's an end game, yeah, there's your career, whatever it is, and the idea is to be sufficiently knowledgeable in various aspects of any topic, right? Even mathematics, just so you can be as efficient as you can be in this. So are you ever going to use this idea to solve a problem like this? Maybe, maybe not, but at least if it does come up, you know how to do it.
Mm-hmm.
All right, the question here is to find x and y. So how do we start? If you look at this, there's 3 triangles, okay? There's the biggest one on the outside, yeah? That has a height of 1.3. What's going to be the base of this?
You add everything up.
Yeah, what does that give? 2.9, 3.8, I believe, meters. Okay,
Mm-hmm.
let's look at the angle x, the one, sorry, with the side length x. What's the base of this?
3.
It's not 3, right? It's going to be 2.9,
Oh,
right? 1.2 plus 1.7 is 2.9. What about the base of y?
just 1.7.
Just 1.7, right? Now what do? We're trying to find x and y.
Um,
Again, find the scale factor, yeah? Let's do for x
mhm.
first. Compare 3.8 with 2.9. What does that give?
1.3.
Right, 1.3. Now the question is, do you divide or do you multiply to get x?
Divide.
Yes. So what will be the answer? It should just be 1, no? 1.3 over 1.3. So x is 1. Now to find y, either you can compare triangle x with y, or you could compare the initial one. Let's go this way. What does this give?
1.4.
Right, 1.4. So what should y be then? We know x is 1.
Um, 0.7.
Oh, yeah, there we go. And that's the answer to this question, okay? The question in this case is to find this length x. How do we do this? There's 2 triangles. They are similar. I mean, you can prove it. They both have a 90 degrees and they both have the pointy thing on the left.
You find the scale factor.
All right, let's find that.
It's 15.
It's 15, that's right. So K is 15. So what does that mean about this side? What's the height of this tower?
You multiply it with 1.85.
Yeah. And what does that give?
27.75.
Right, 27.75. Now, how do we find the hypotenuse of this triangle?
You just square the other two numbers and then add them.
Try that. Tell me what you get.
$29.2.
Right, you square rooted it, yeah?
Mm-hmm.
There we go, and that's the answer to this question. Similar triangles, pretty simple. Let's try doing some trig. Well, we are doing trig, but we're gonna use sine cos tan. 5a, it says determine 3 primary ratios. Now, what does primary ratio mean? They just want sine A, okay, for angle A. So we gotta look, this is gonna be our frame of reference. We gotta look at it from that angle's perspective. Sine A, cosine A, and tan A. So sine is so, right? So CAH TOA. So step 1, we don't have the hypotenuse. So let's find the hypotenuse of this triangle. What will that be?
Um, 8.9.
Right, 8.9. So sine A, sine is opposite over the hypotenuse. Yeah, we're looking at it from this perspective. So it's going to be 4 over 8.9. What's cosine going to be? Cos is the adjacent over the hypotenuse, right? So the adjacent from this angle's perspective would be
8.
yeah, exactly, 8 over 8.9. And tan is just the opposite, so 4 over 8. So that's tan A is 4 over 8, which is a half, okay?
Mhm.
That one we can kind of reduce it. B is asking us to find angle A now. And we're going to use this one to find it. Do you remember how to do this? We know what the ratio is, or we know what it comes out to. How do we find the angle?
Um,
You do the second function thing, yeah? When the angle is missing, you do the second function thing, magic.
okay.
So why don't you try it? Put 0.5 on your calculator and then press second function tan.
26.56.
Yeah, exactly. It says to the nearest degree, so we're just going to round it to 27 degrees. Cool?
Okay.
Yeah, there we go. So it's pretty simple. This one we don't have to do both of them. Let's do just one of them. We're trying to find what x is. Now this would be if you want to draw a diagram of this, x is here. We know the adjacent because cos is the adjacent over hypotenuse. Actually, x is not there. X is going to be the hypotenuse, and we know the angle is 29. So that's a visual representation of this problem. But on surface level, it's just an equation. How do you solve this equation for x?
You multiply x on both sides.
Yes, you multiply x on both sides. And then?
And then you divide.
Yes, so 17.3 divided by cos 29. Why don't you try plugging this in? because this unit is also, it tests your calculator prowess.
$19.8.
Yes. And there we go. Okay. And we know it should have been bigger than the side length because the X there represents the hypotenuse of that triangle. ABCD is a rectangle. So what's the property of rectangle? All they have 90 degrees everywhere, yeah? At least in the corners. And this one's saying if AB is 15, well, if this is 15, then this must be 15. And BC is 10, so this must be 10. They want the angle BAC, so they want this angle. How do we solve that? So what's the approach here? So look at X. Relative to X, which two sides do we know? Opposite, adjacent, hypotenuse.
The opposite and adjacent.
Right, the opposite is 10, the adjacent is 15. Hypotenuse, we don't know what it is, but we can find it, okay, but we don't need it. We're trying to find the angle. Which ratio uses O and A?
10.
10, exactly. So let's set it up. 10x is equals to 10 over 15, yeah? How do we solve this for x?
You multiply by 15.
No, you don't. We're trying to find the angle x. You're thinking of something like this. Cos 29 is 10 over x. In this one, you would multiply by x on both sides, okay? Or you'd multiply the denominator on both sides. In this one, you don't, because we're trying to find x. To solve
So
this,
you just divide?
Yeah, you just divide this and then do second function tan.
Okay. It's 33.69.
We'll check that. Yeah, there we go, 33.69. And then it says to the nearest degree, we're just going to round it up to 37. Boom, done. One end done.
Okay.
This one says solve this triangle. When it says solve, it basically means give me everything that we don't know yet. Let's first find what this is. This angle on the top, theta, it's called, this one. You can find that really quickly. What do we do?
Oh, you subtract 90 and 18 from 180?
Yeah, exactly. And that should give you, I believe, 72 degrees, 90 minus 18. Okay, so theta is 72. Let's work from 18 degrees perspective. Okay, we're looking at it from this guy. What's the opposite? What's the adjacent? And what's the hypotenuse?
The opposite is 9.
Yeah. The adjacent is
B.
B. And what's the hypotenuse?
A.
A, right? So what are we trying to find? We're trying to find A and B. So you can't use these two, okay? Because you see, we don't know either one of them. So the approach here would be to use this with this and this with this to find the missing variables. So opposite and adjacent, that's tan. Tan 18 is equals to the opposite over the adjacent, like that. How do we
Mhm.
solve this equation for B?
You multiply B.
Yes, you multiply B and then
You divide by 9.
you divide by 9. Think about it, that won't work because you'll just get a 1 on this side and you'll get something else. Now, not divide by 9. We'll try to isolate B. Divide by 1018,
Oh, okay.
right? Not 9. 9 won't
Mhm.
help us. It's going to be B equals 9 over 1018. 9 divided by 1018. And that's 27. I guess we can round it up to 27.69. Can round it up to 28. Okay, then centimeters. So we
Mhm.
know this guy at the bottom is 28. How do we find A? By A, I mean, in this case, it's the hypotenuse of the triangle, the unknown.
Um, you could use sine.
All right, let's use sine. So sine 18 is equals to 9 over the hypotenuse, which for us is A.
You multiply by A first.
Yes, A times sine 18 equals 9, and then?
You divide by sine 18.
Right, so 9 divided by sine 18, so A is 29, and we are done. Okay,
Mhm.
simple as that. Let's try doing a word problem, which is going to be a little bit more difficult. Right, do you remember what angle of elevation was?
Like when you look up.
Yeah, when you look up. So there is a building that is 16 meters tall. And from here, the angle of elevation, there's a second building, okay? It's a second taller building. And when you look at it from here, we get an angle of elevation of 48 degrees. Okay,
Mhm.
and we know there's going to be a right angle here, and we know that the distance between the two buildings is what, 30 meters. So you see from here to here, the distance between them is 30 meters. Actually, maybe that won't help you in the triangle, like from here to here. We're trying to find the height of this second building. How do we do this?
Um,
Any ideas?
you could use tan.
Yes, that's perfect. You are gonna use 10 because we need to first find this opposite side, right? Let's just call this O. So O is the distance from there to there, yeah?
Mhm.
So we get tan 48 is equals to the opposite, and the adjacent for us is 30, yeah? How do we solve this equation for O?
You multiply by 30.
Good. Multiply by 30 on both sides. So tan 48 times 30, and that gives us O is 33.32 meters. So if O is that, what's the total height of the second building?
You add 16 meters.
Yes, you add 16 to this, and you should get, what's this, 49.32 meters, and we're done.
Mhm.
And something like this is used extensively in fields such as surveying. Let's do one more here. Calculate the length of AB. So we're trying to find this length. can call that x, I guess. How do we do this one?
You have to find like the length of both the triangles.
Yes, correct. So you have to first find, well, let me just split them up if it helps you. What's the angle if we're looking at the big one? What's angle C here? We know the base is going to be 100 for both the triangles.
Mm-hmm.
If you look at CAD, what's angle C?
40 degrees.
Correct, 40 degrees. And this one will be 20 degrees. So how do we find AD here? Maybe sine, cosine, or tan?
Tan.
Correct. So tan 40 is going to be AD, or whatever, O, over 100, yeah? And you can
Mm-hmm.
multiply both sides by 100. 100 times tan 40. So AD would be 90. Okay.
Mm-hmm.
What about for the triangle CBD? How do we find BD?
You use tan again.
Yeah, use tan again. This should have been 84. So tan 20 is equals to BD over 100. Again, multiply both sides by 100 times tan 20. And that gives us BD is 37. So we know from here to here it's 37. And we know the whole thing is 84 from A to D. How do we find A to B?
You subtract.
Yeah, you subtract. So 84 minus 37. Therefore, that missing length A to B is 47 meters.
Mm-hmm.
I don't know if this diagram has anything to do with this. Looks like it does. All right, the swimmer is at point A. He's looking at some point D. When the swimmer swims towards the cliff for 1.5 minutes, so from here to here, he swam for 1.5 minutes. And now he's looking at the top of the cliff again, but the angle is different. The height of the cliff is 70. Calculate the distance the swimmer swam. So what are we looking for in this case?
The adjacent.
So which AB, AC, BC?
A and C.
No, he doesn't swim all the way to the base of the cliff, right?
Just AB.
Yeah, just AB. So the unknown here is AB. In a question like this, I think it's easiest if you just split them up into two different triangles so you don't get confused. You don't have to do this, but it'll help. So there's our first triangle. And then we have a skinnier one here with CBD, and they're both 70. To find AB, we could first find AC, right? And then we can subtract BC from that. So what do we use? Sine, cos, tan.
Tan.
Yes, correct. So we do tan 30 is equals to 70 over AC, yeah? On the other one, we could do tan 45 is equals to 70 over BC. How do we solve for AC here?
You multiply by AC.
And then, do you divide by 70 or divide by tan 30?
Tan 30.
Yes. So this gives you 121. And you do the exact same thing here. This gives you exactly 70. Okay, and then you can just subtract one from the other. The answer there will be 51 meters, and you're done. Cool. What if I asked you, what was his speed? What was his swimming speed from A to B? We know the distance is 51 and he swam for 1.5 minutes. So a question could be, how fast does he swim?
Um, 51 minutes. 51 meters per 1.5 minutes.
Yeah, but you need to have a 1 in the denominator. So you just plug that in a calculator. He swam 51 meters and it took him 1.5 minutes. So that means 51 divided by 1.5, he swims at 34 meters per minute. Okay,
Okay.
you need to have a 1 in the denominator. So that's his speed. Let's see if there's anything fun here. Okay, let's try doing when angles are missing. And notice so far we've been doing trig in 2D, okay?
Mhm.
In real life, it will be in 3 dimensions. Because yeah, we live in 3 dimensions. So I mean, you can always use a 2-dimensional approach, but I don't know if we'll do the 3-dimensional ones. It's the same thing. It's just there's gonna be an extra like depth to the, there's gonna be something like there's gonna be an extra layer to the triangle, but the math is very similar. Let's look at this one. Jane is on the 5th floor. So let's say this is the building. She's right there. And this is 16 meters from the ground. She spots her car and estimates that it's parked 20 meters from the base of the building. So let's say this is her car, okay?
Mhm.
We can call this point A. And which side is 20, BC or AC?
BC.
Yes, BC is 20. And what's the question asking you? Determine the angle of depression to the nearest degree. Now, where is the angle of depression?
Is it C?
No, angle of depression and elevation is always, you see, this one is elevation, this one is depression. So it's not, it can't be at C because she's at A, her eyes is at A, yeah? You see this?
Mhm.
This is her eyesight. The angle of depression, is it gonna be the inside part or the outside part?
Inside.
No, it's gonna be the outside part, okay? It's always from the horizontal line. You see this line, horizontal line side?
Uh-huh.
Angle of elevation and depression are both going to be, it's gonna come out from the horizontal line. It's not gonna be this one.
Okay.
But we may have to find this one to find that one. Or if you remember parallel lines, how is this angle and this angle related? These 2 lines are parallel. It's gonna be the Z rule, right? Z rule. How are these 2 angles related? They're gonna be the same. Okay,
Mhm.
whatever that angle is on the outside, using the Z rule. Now, what is that Z rule? We have done this. You see this angle is gonna be the same thing as this angle because these 2 lines are parallel.
Uh-huh.
So if we have angle C, we have our final answer. Okay,
Okay.
so the question is, how do we find angle C? Sine, cos, tan.
Um.
Sine, cos, or tan. Again, we're trying to find angle C, okay? I'm trying to find this one.
Which one do you use?
Again, look at what you're given, right? So from relative to angle C, which two things do you have?
The opposite.
Yeah, the opposite is 16, the adjacent is 20. Hypotenuse we don't need because we have two things. When the angle's missing, you just need two things. So which one, sine, cos, or tan?
Tan.
Yes. So tan of C is going to be opposite 16 over 20, yeah? So tan C, I think you can do this, right? This is going to be 0.8, 16 over 20. So what's angle C going to be if tan C is 0.8? Just do 0.8 first and then do second function tan. That should give you the angle.
Is it 38.7?
Yeah, and then we can just say it's 39. And we have it, okay? If angle C is 39, that means this angle on the outside, which is the angle of depression, also must be 39. All right, this one, there's no diagram, there's no nothing, but we didn't have one in the previous question either. So let's look at this. A pilot who is heading due north spots two forest fires. So north means up, okay? So he's going this way. So let's say he's right here at this point. He's right here. The fire that is due east is an angle of depression of 47 degrees. What does that mean? That means there is a fire here, okay? Call that E or whatever, east. And it's at an angle of depression. So again, think about it. We're going to draw a line here. I mean, we know this is going to end up turning into a triangle. Which angle is 47? The one on the inside or the one on the outside?
Outside.
Right, this angle is 47, okay? This angle is 47. And then there's another one on the west side. So let's say this other forest fire is here on the west. And that is at an angle of 38 degrees, yeah? Like that, that's at an angle of 38. And we can just join this to form the triangle. Now the question is, if this is 38, which angle inside the triangle is also 38?
W.
W, correct. Using the Z rule, W must be 38. What about 47? That's E, right? Like that? So there you go, that's our triangle. And we do know the altitude of the plane is 2400. So which side length is 2400?
Like the height. I don't know.
Yeah, the height. So which side length is that?
Do you make a line in the middle?
Yes, you do. That's exactly what you do. So you make a line in the middle. This is gonna be your 90 degree, okay? And the height is 2400. There we go. It's asking us the distance between the two fires. So which side length is the unknown here? The first fire is here, the second fire is here, right? We're looking for WE, okay? WE is our unknown. So what's the approach in this question? .
You do both triangles separately?
Yes, exactly. You'll first find WO, and then you add with OE, yeah?
Mm-hmm.
So let's look at the one on the left. We know the opposite is 2400. Is WO the adjacent or the hypotenuse?
The adjacent?
Right, so the adjacent is WO. So again, O and A, you notice how we use tan most of the times?
Mhm.
So tan 38 is gonna be equals to the opposite, which is 2400, divided by the unknown, okay? How do you solve this for WO?
You multiply WO first.
Yes, and then?
You divide by tan 38.
Exactly, so I can just do this in one step. This will be this, and the other one will be 2400 divided by tan 47, and that one is OE 2238. And now we have this and we have this. We want the total distance. We will just add them up, right?
Mm-hmm.
So the whole distance is 5310, and we're done.
Okay.
All right, now let's do something that we haven't quite done yet, and this is called sine and cosine law. Basically, so far everything we've done in this unit, we always had a right angle, yeah?
Mm-hmm.
We always had a right angle. But the thing is, that's not always going to happen. For example, let's say this is 30, yeah? Let's say this is 80, and then this one will be whatever's left. That's 70, okay? Let's say this is 3 meters. Now the question is, how can we find BC and AC? We can't use SOH CAH TOA because SOH CAH TOA is strictly only for right angle triangles. Same thing with the Pythagoras theorem. Okay, so when you encounter a non-right angle triangle, you need to use something called sine law or cosine law. And let me show you what that looks like. Sine law says, okay, well, it has two variations, but they kind of both give you the same thing. It depends on which one is missing. In this case, side lengths are missing. So we're going to introduce some new variables. You see this side that's opposite to A,
Mm-hmm.
that becomes small a, okay? This side that's opposite to B becomes small b. The side that's opposite to angle C becomes small c. And sine law says this: A over sine A is equals to B over sine B. That is equals to C over sine C. Now there's a triple thing going on in this equation, but we don't actually use the triple. We use two things at a time. Okay, so we'll either use just this, or we'll use just this, or we'll use the first and the third, depending on the question.
Mm-hmm.
So let me work this out for you. So let's look at, let's find A, okay? So to find A, we're just gonna do, we don't know what it is. So it's gonna be A over sine of A, sine 30, like that, yeah?
Mm-hmm.
Equals to, now we can't use B because we don't know what that is. So we're gonna use A and C together. What's side length C? That is known.
3.
3. And what's sine of C? So sine of 70. There we go. That's how you'd find A, okay? How do
Okay.
you solve this equation for A? What do you do on both sides? You'd
Do you
multiply by,
multiply?
yeah, you'd multiply by the denominator, yeah? Because we're trying to isolate A. So A
Oh,
is gonna
okay.
be 3 times something like this. Why don't you plug this in your calculator and tell me what you get?
Is it 1.5?
Right, 3 times sine 30 divided by sine 70. Yes, it is 1.59, yeah? So I
Mhm.
can just say that's 1.6. There we go. Now we also want to find B. To find B, we can now use everything because we know what A is. A is like 1.6. So look at the setup here. It's going to be B over sine of B, so sine of 80. That is equals to whatever, A over sine of that. So A over sine of A, sine of 30. There we go, like that. Okay.
Mhm.
What do we do on both sides to solve for B?
You multiply again.
Yeah, you multiply. So B is going to be 1.6 over sine 30 times sine 80 and whatever that is on a calculator, okay? And that's the sine law. How does the book write it? They write it the same. They write it like this. But you won't be using triple ever. You'll just be using two things at a time.
Mhm.
Let's try solving some equations. Now this is just the variation of that formula. In this case, it's asking us to find what m is. They've already plugged in the numbers. In this one, the angle is missing. Okay, the example that we just did, the side length was missing and it was in the numerator. Here, the angle is missing and it's in the denominator. But the math is very similar. It's just a linear equation. How do we solve this?
You multiply it.
Multiply what on both sides?
Um.
Multiply sine m, yeah?
Mhm.
If the unknown is in the denominator, always multiply that on both sides. So we're going to do this. Sine m, we're going to throw it onto the right side. And boom. Now what do we do? I guess we could evaluate what 10 over sine this is, right? So we have 6 there, and then 10 divided by sine 72, that is 10.5 times sine m. How do we solve this equation for m?
You divide.
What? Divide
Um.
which guy on both sides?
10.5.
Correct, because if you divide sine m on both sides, you literally go back to the same step that we had before. So we'd divide 10.5 here, and we would divide 10.5 here. This cancels out. We're just left with sine m on this side, yeah? The other
Mhm.
side, we have 6 divided by 10.5, which is 0.57. And we're looking for m, not sine m. How do we find m from here?
You use the second function.
Yeah, try it. Tell me what you get.
$34.75.
All right, we can just say it's 35 and we're done. 35 degrees is angle m, okay?
Okay.
And that's when the angle is kind of missing. Let's try this one. It says determine the length of AC. So AC is here, yeah? Now what we can do is we can put the labels in. This is A, that is small b, and that is small c. So we're looking for side length b there, yeah?
Mhm.
The formula is this one, A over sine A equals B over sine B equals C over sine C. So tell me, what will help us find B? Small letter b, which denotes the side length. How do we set this up? And again, we only use two things at a time. If you look
A
at,
over sine 80.
we do know what A is, right? A is 12. A over sine 80, yes. And that is equals to what?
B.
B, yeah, B over sine 55, right? Like that.
Mm-hmm.
Yeah, you can't use B and C here because they're both unknowns. You can only have one unknown at a time, right? So we couldn't have used this one in this case. We had to use A and B. And then to solve this equation, you just multiply by sine 55 on both sides, right? That gives you 10 almost, 9.98. Cool?
Mm-hmm. Uh-huh.
Let's try it in this one. In a triangle DST, and again, none of these are going to be right angled, because if they were, we could have just used SOH CAH TOA. So DST, again, let's just make a random triangle, DST. Angle D is 47, and small letter d is on the opposite side, okay?
Mm-hmm.
And S is 106, so again, S is going to be opposite that. This is 106. And the question is to find angle S. How do we set this up? And again, this is the formula, right? A over sine A, but the letters don't have to be A and B, they can be anything. What that basically means is it's going to be side length over its opposite angle equals to some side length over its opposite angle. Yeah. So here, let me set this up for you. We're trying to find this, okay? This is our unknown, yes?
Mm-hmm.
Angle S. So it's going to be side length, some side length that we do know, 78 over its opposite angle, right? Like that. And that is equals to 106 because we're trying to find S over sine of S, like that. And we have done an equation like this before. How do we solve this equation? What do we do first?
You multiply by sine 47?
No, not sine 47. If the unknown is in the denominator, always multiply the unknown on both sides. So we'd multiply both sides by sine S.
Mm-hmm.
Okay. So you'll get, again, I can plug this in the calculator, 78 divided by sine 47, that is 106. So we have sine S times 106 equals 106. You see that?
Mm-hmm.
So divide 106 on both sides, sine S is 1 and S is 90 degrees. So actually, I don't know if it's going to be approximately 90 degrees, yeah, because I didn't plug the correct or the decimal values for these. And that's how you do a problem that has no right angles in it, okay? Or that's how you apply the sine law. Alrighty, let's call it a day there for today.
All right, thank you.
I'll see you next time. Bye-bye.